Hi everyone, my name's Denise. On Twitter, I'm Denise Yu 21, and this is Site Reliability Engineering for Cats. Thank you so much to the DevOps States Buffalo team for having me. I'm very excited to be here today. So I bet a lot of you are wondering, why should we think about SRE principles in terms of cats and vice versa? And the only way that I can answer that is to start by telling you a story. In April 2019, I got a cat. His name is Sam. He was extremely cute when he was a tiny kitten, and this is actually my first time ever owning my own pet as an adult. Have you ever had a 3-month-old kitten before? They're a lot of fun, but they don't really like to follow rules. So, see that thing in the corner? That is a $30 cat bed that I bought for him, but instead he chooses to sleep on the corner of my bed every day. What I'm trying to express here is that cats are unrelenting agents of chaos. At Google, they run these disaster readiness drills, and their big doomsday scenario is called Catzilla, literally a giant cat stomping on and destroying their data centers. So at least one other person out there agrees with me that cats can teach us a lot about designing for failure in large distributed systems. I want to share with you 3 lessons today about what cats can teach us about reliability engineering and vice versa. The first of these lessons is to set realistic and sustainable SLOs. SLOs are goal statements, like we want our service to be reachable 99.99% of the time, which translates to roughly 52 minutes of downtime each year. An unrealistic SLO is 100% uptime. So we live in a condo with a lot of neighbors. Every time the front door opens, Sam bolts out the door. And we used to chase him, but then he started escaping more because he learned that if he runs out, he gets to play a fun game of tag with the humans, which made him want to escape even more. So some bad feedback loops happening there. So we started letting him out for just a few minutes a day, no more than 5 minutes, just to show him that there's nothing special, there's nothing interesting out there, it's just a boring hallway, and he burns off some energy. So 99% of cat in flat time was a much more realistic SLO for us. The purpose of an SLO is to establish an experimental baseline. If you're on track to surpass your SLOs, like, in other words, you have room in your error budget, it means you have the freedom to run experiments during the rest of your cycle. SLOs shouldn't be so hard to achieve that teams spend all their time trying to land their targets, but they should strike that balance of being realistic enough to be attainable, but ambitious enough to make you want to improve. Second lesson, eliminate the toilsome things so that we as humans can invest our time on solving interesting problems. There are a lot of applications of cat ownership here. For example, we spent a lot of our time toiling and picking up food that he would knock out of his bowl. It would end up literally all over the floor. And then I realized, hang on, I've been working in DevOps for a couple of years. I already know the solution to this. All I have to do is containerize my workflow to reduce toilsome side effects so that we could focus on the higher order problem of how do we become the best cat owners in the world. Lesson number 3, shit's just gonna fail. Even the most resiliently designed system is going to have some kind of upstream failure at some point that you can't prepare for. So we should optimize for learning. Even very often after a big bad outage happens, teams hold incident reviews, which are conversations to try to pinpoint the root causes. But I actually suggest that if you want to learn, we should worry less about root cause analysis and think more broadly about contributing factors. Acknowledging that 2 incidents will rarely look the same because we operate in these highly complex environments will actually enable us to have richer and more blameless conversations. But wait, what does it mean to have a blameless incident review or a blameless postmortem? Well, of course, the first thing is we don't assign blame, and we don't worry about things like justice. A useful guideline to know whether your incident reviews are blame-free is to ask yourself, are you thinking in terms of counterfactuals? Counterfactuals are statements like, had you done this and this wouldn't have happened. Because if you are having counterfactuals, then stop right there. It's not productive. In addition to having safe postmortem processes, I think it's worth spending time thinking about how to design the systems that we're going to be using. Jason learned from his cat Percy that a lot of what it means to be a good cat owner is to carefully think about the environment that you've designed. Similarly, for resilience engineering, is it more likely that someone will make the right decision after reading a 30-page runbook at 3 a.m., or are they more likely to make the right choice if they only have 1 or 2 possible options clearly laid out in front of them? In closing, failure is ever present in modern software systems. And I think that given that this is inevitable, the best thing we can do for ourselves is to equip ourselves with practices and tools that let us focus on the important things in a sustainable way. And that, of course, is all in service of letting us all go the frack to sleep. Thank you so much for having me. If you want to check out the slides, they're on my website. Have a great conference.
Hi, I'm Tim Davis, DevOps advocate with M0, and today I'm going to be talking to you about the pitfalls of infrastructure as code and how to avoid them. So, about me, I'm a DevOps advocate. I've been a cloud developer advocate, an enterprise architect, and an infrastructure operations person, also a systems administrator, tech support, pretty much everything on the infrastructure and operations side of the house. So, what is infrastructure as code? It's really infrastructure and code with going through and instead of racking and stacking and deploying or going into a graphical user interface and clicking around and doing what you need to do, you're packaging up code and then deploying it out using some form of framework. Now, what are some of the types of issues that can come up or pitfalls that can come up with that? I've got good and bad news for you. It's a lot. It's most of the pitfalls that can come around with infrastructure and most of the pitfalls that can come around with code. But if you actually go through and you use your operations team, you use your development team's experience and everything, kind of bring everybody together, you can really utilize that wealth of experience to solve a lot of these problems pretty easily. Let's break it down into some of the infrastructure pitfalls. Now, the very first one is choosing the wrong framework. So you want to make sure from the beginning that you choose the right framework. Do you choose a cloud agnostic framework like a Terraform, Pulumi, or Terragrunt? Or do you choose a cloud specific one like an ARM or a CloudFormation? Making sure that you do this is very important. Security, you want to make sure that you're bringing them into the conversation, that they've got a view of what's going on from the beginning. Of course, there are tools that can help you solve these problems with infrastructure as code before they happen, like Terrascan or Chekhov, so that you know what's going on and that you're not deploying out an S3 bucket or something like that with an open policy. So let's see some of the code pitfalls. Default values. What happens when you leave a value blank? In AWS or something like that, when you deploy out using the wizard, it'll make sure that you're looking at all the different things that you need to specify, like names and policies and stuff. But when you're writing that code, you got to make sure that you have that because you don't want to accidentally go through and deploy something without a value and it just attaches a default value to it that you might not want. Things like Open Policy Agent can help you by validating a deployment has values for something or that it's got a specific set of values. So policy is code, security is code, infrastructure is code. I think you're starting to see a little bit of a theme here. Now, don't repeat yourself. It's a coding methodology that helps you break down code into more repeatable pieces. Now, how do we mitigate dry issues with code? So utilizing things like Terraform modules or Terragrunt can help you break up that code into more reusable pieces so that you don't have 5 different copies of the same code with hard-coded values. When you deploy stuff with infrastructure as code, you're designing for state size, or you should design for state size. So with that, you're not going through and checking every single resource when you only need to update your, say, EC2 instances. So how do we mitigate state size issues and performance issues that can come along with that? The good news is we just learned that. The don't repeat yourself methodology. If you utilize those things like Terraform modules and Terragrunt, it can help you to break up your code into those more reusable pieces. But also when you're going through and automating for the deployment, it'll break it up into smaller state files instead of one giant one. So that when you need to deploy that, if you just need to update your EC2 instances from 3 to 4, it's not going to go through and have to check the VPC, the RDS instances, the IAM policies and everything. It's only going to check what you need, so your deployment's going to finish faster. Now, if you want to learn more, please feel free to follow me at VTimD. I know this was a lot of information pretty quickly. I want to thank the DevOps Days Buffalo folks for having me for this lightning talk. I wish I could be there in person, so hopefully I will see you next year, and enjoy the rest of the show.
Hello everyone, glad to be here at DevOps Days Buffalo. And today I'd like to talk to you about the state of DevOps. I'm going to use data from DevOps Pulse. This is a yearly survey we run, essentially a questionnaire that people like you answer. Over 1,000 people answered the last survey from various companies, from startups all the way to enterprises, from different countries, different industries. The survey covers many areas. I'd like to use the coming minutes to look into some common assumptions around cloud and cloud native, on what people use, what the issues were, what the solutions they used, and to check how these assumptions hold true in light of the results. My name is Dotan Horovits. I'm a developer advocate at logs.io. I'm an advocate of open source and communities. I organize the CNCF chapter in Tel Aviv. I run the Open Observability Talks podcast. And let's move on to the first assumption. Everybody's in AWS. True? False? AWS still rules, not a surprise, 2/3 rather. More interesting in this survey is that Google Cloud is catching up with Azure in the race for the second place. And still, we need to remember that both of them are far behind AWS with around 11-12%, and the rest are pretty much non-existent. So AWS rules, and the next assumption, everything's containerized. True? Quite true. Over 50% said that more than half of their apps are already containerized, and 30% said that over 3/4 of their apps are containerized, which is astonishing. And it's not just young startups who responded, but also enterprises with over 1,000 employees. So containerization is definitely happening across the board. Which leads me to the next assumption. Kubernetes. Piece of cake. True? Well, not really. People report challenges across the board. Number one difficulty is with monitoring and troubleshooting, 44%, but also people reported issues with security and networking and cluster management and storage, you name it. In short, everyone's moving to containers, but they still don't know how to manage them, how to do it right, simple, production ready. And the number one challenge is with monitoring and troubleshooting, which leads me to the next assumption. Just use logs and metrics. What's the issue? We've been doing that for years. And indeed, 90% use logging tools and 78% use metrics tools. Not surprising. What is interesting in this survey is the rise of distributed tracing that increased by 38% from the previous survey. And among those who don't yet use distributed tracing, 64% are planning to start using it in the coming 1 or 2 years. So tracing definitely stands out as a central tool for monitoring microservices and distributed systems in general, obviously on top of logging and metrics. So let's summarize. Everyone's moving their workloads to containers and Kubernetes, but they're still experiencing many challenges operating Kubernetes in production, with monitoring and troubleshooting being the top challenge, 44%, and distributed tracing is rising in popularity for that purpose of monitoring and troubleshooting microservices. And what about serverless? What about service mesh, open source, edge computing? You can see the full survey on this link with all of these topics and much more. So check out the DevOps Pulse 2020. And wait, you can influence the stats. We just launched the 2021 questionnaire, so you're more than welcome to participate and answer and give us your take of the industry. So just go to DevOps Pulse 2021 and answer your take. And of course, you're more than welcome to reach out to me and share your feedback, your questions, your comments here on the Q&A chat or on Twitter @Horovits, or whichever way. I'd be more than happy to reach out and chat. I'm Dotan Horovits, and thank you very much for listening.